So, good morning everyone. I am Sanidhya Kaushik.
I am Ayush Raina.
I'm Arnav Bhatt. And we stand before you all to present this very interesting paradox known as Gabriel's horn. So, what is a Gabriel's horn? So, basically, the name comes from a Christian tradition where an archangel blows a horn to announce a judgment day. It has got nothing to do with mathematics. So, this is how exactly a Gabriel's horn is formed. So we plot a rectangular hyperbola, say xy equals 1, limited to a domain x greater than or equal to 1, and then we rotate it about x-axis. So this gives us this horn-like looking figure.
So far, many arguments have been put forward. Wait. Let's try to calculate some of the parameters relating to this horn.
Many arguments have been put forward for what?
Yeah, that is the advantage. First, we will try to calculate the volume of this Gabriel horn. First of all, we will divide this partition this horn into infinite cylinders of thickness dx. Then, at radius of each cylinder will be the function value at which the cylinder is located. That is 1 by s. On putting the value of thickness and radius in the volume expression and integrating over the interval 1 to a, we will get the required expression for volume. We can clearly see that as a tends to infinity, volume tends to pi, and this proves that volume is finite. And in case of calculating the area, we have to partition the all into infinite customs of thickness dx, and radius will be same as 1 by x. On putting the same radius and thickness values into the area expression, we will get the required area will be greater than the 2 pi ln a. As the a tends to infinity, the 2 pi ln a also tends to infinity, and this proves that area is infinite of this horn.
So it's quite now it might seem quite fishy for the area to be infinite but the volume to be finite, because it's seldom that we see such a case. So now let me try to back these results up with the concept of series. While calculating the volume, it is evident that volume of one cylinder is proportional to r square. R here is 1 by x. So while integrating, we are basically summing up a series of 1 by n square. And we know that this series converges. Hence, it is not that unusual for volume to be finite. But while calculating the area of one frustum is proportional to the radius. So radius here is 1 by x. So while integrating, we are basically summing up a series of 1 by n, which diverges. So it makes sense for area to be infinite.
What's the paradox here? The paradox arises when we take the thickness of the horn to be negligible. In this case, the inner surface area and the outer surface area are nearly the same. However, like now imagine yourself filling the horn with 5 units of paint. Naturally, in this process of filling the horn with 5 units of paint, we are painting the inner surface area. However, when we try to paint the outer surface area, we need an infinite amount of paint because the surface area is infinite. There is a contradiction, and this is the paradox.
So, interestingly, at the time these calculations were made, Aristotle's dictum was quite prevalent, and it states that there cannot be any relation between finite and the infinite. But seemingly, these results of Torricelli's contradict this dictum. So many supporters of Aristotle tried to directly disprove these results, these calculations, as at the time these calculations were made, calculus was not introduced. But they weren't able to do this. And other supporters of Aristotle tried to offer some reinterpretation of Aristotle's.
So far, many arguments have been made to solve this paradox. Like there were arguments like several attempts in which it was also discussed that it is not possible to construct such a horn in real life. So it is meaningless to discuss how to paint it.
Some other school of thought argues that if we are using a real life paint, then we must have a real life constraint on the horn as well. Like the length of the horn should terminate when the radius of the horn becomes less than the radius of the paint molecule. In this case, we get a finite length, and thus we have a finite surface area, which basically solves the problem.
Some people also supported postulating a mathematical paint which is infinitely thin and thins at an appropriate rate, so that when length approaches to infinity, the thickness decreases. But none of the above arguments was seen to solve the paradox, thin horn problem satisfactorily.
So postulating in mathematical paint with these properties just gives us the ability to paint the horn, and it just justifies the existence of such a figure. But the real problem here is that we are able to paint the inner surface area with less than 5 minutes of paint seemingly, but the outer surface area needs infinite amount of paint. So that remains unsolved even here. I would like to conclude this presentation with a very interesting fact. So when these calculations were made, this French philosopher, Mr. Gaston Parry, tried to prove the existence of God on the basis of these calculations. So he argued that a finite human like Torricelli is able to comprehend the infinity. So humans must in some way consist of more than matter. So he argued that humans also consist of some immaterial souls, hence God exists. I know it's quite a vague argument, but these are exactly the words of Mr. Yasmin Khan. So that's it from our side. Thank you. Thank you very much.